Hello class, we're about to start Unit 4, Exact Linear Relationships. So far we've learned about how to evaluate expressions and formulas using the order of arithmetic operations, how to translate between different units of measurement, how to design studies and collect data to answer questions, and also how to measure likelihood of and talk about possible future events, which is probability. Now, we're going to start thinking about how we can use data to make accurate estimates and predictions based on mathematical models. This is at the very heart of how mathematics is used in the modern world. In order to do this, we need to develop a way of thinking about how the mathematics and statistics that we do relates to the real world out there. Any model we want to use will probably have at least 4 different interpretations, as shown here. We have equations and algebraic expressions, listing table, graphs, and also words, and this is all used in the real world. Now basically, the more ways we have to translate information about the real world, the better our models and predictions will be about it. This means we need to build up our repertoire for making graphs, tables, equations, and translating between them all in useful ways. Now we come here to topic 1, creating scatter diagrams. We have the independent variable, also known as the explanatory variable. A variable whose value determines the value of other variables, typically represented by the letter X in algebra and statistics. We have the dependent variable, also known as the response variable. A variable whose value is determined by, i.e., it depends upon the value of the independent variable, typically represented by the letter Y. The letters X and Y are the generic stand-ins we'll use for all variables. Now we go to example 1. For each situation, identify the independent variable and the dependent variable. Okay, it says here the number of words in a document and the time it takes to type the document. Now the independent variable would be the words, and the dependent would be the time. Now we come here to B, the ages and heights of people waiting at a bus stop. So the independent is age, and the dependent is height. Now we come to C, the length of a person's hair in inches and the number of weeks since her last haircut. The independent is the weeks. Dependent is the length of hair. So we come to D, the amount of time it takes for a nurse to do his rounds and the number of patients in the ward where the nurse works. So the independent would be the number of patients, and the dependent would be the time. Now, it says, and blank is a pair of numbers in the form of X, Y. That is called an ordered pair. The first number is the independent, or explanatory variable, and it's called the X coordinate. The second number is the dependent, or response variable, and it's called the Y coordinate. So now we start example 2. The rates of MRSA infections reported for various years are shown below. Now, we're asked with A, what are the independent and dependent variables in this situation? Okay, now the independent is actually the years. And the dependent is the MRSA. Now it says here, list 3 ordered pairs from this set of data. Okay, first of all, since we determined whenever you have a table, it's typically set up with the independent first and the dependent second. Now I say in most situations this is the case. And we also listed it here. So years is really your X and the MRSA is really your Y. So we know ordered pairs are written as X comma Y. And for B, they asked us to list 3 of these. So what we could do is this here. It doesn't matter which 3. We got 2003 and then 21. We got 2004 and then 23. And 2008 and also 42. And those are 3 ordered pairs. Now we have the Cartesian coordinate system. When we plot points that ordered pairs, well, when we plot points that are ordered pairs, we call the horizontal axis the x-axis and the vertical axis the y-axis. By plotting a point, we are effectively locating a spot by moving distances along 2 perpendicular number lines. The coordinate system is labeled as follows. Okay, now, this right here, the horizontal line here would be the x-axis. The vertical line here would be the y-axis. Now, we have this point here where the x and y-axis meet. It's called the origin. And this ordered pair is 0, 0. This is when the independent and dependent variable are both 0, or x and y are both 0. Now, what we have here, and let me make this just a little smaller so I can get this whole graph in here. Okay, skipped around a little bit. Let's go back here. Okay, now, what we have here, these 4 boxes here, these describe the quadrants. Now, quadrants are typically written with just a Roman numeral. So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. These are the quadrants. Now, if you need the spelling of quadrant, you can put them in front of each one of them, but this is what quadrant is spelled as. So this would be quadrant 1, and quadrant 2, quadrant 3, quadrant 4. Now, the importance of knowing the quadrants. Any value that does not rest on the y or x axis is in one of these quadrants. So, what the quadrants does is it gives you the characteristics of the values that will be in your ordered pair. So, for instance, x will be positive in quadrant 1 and y will be positive. In quadrant 2, x will be negative, y will be positive. Quadrant 3, x and y are both negative. In quadrant 4, you have x will be positive and y will be negative. Now, if the numbers rest on the x and y axis, one of the x and y values would be 0, or if it rests on the origin, both would be 0. So they would not be in one of the quadrants. Now, scroll on to the next page. It says plot the following ordered pairs on the graph below and label each of them. Okay, so now this is how you do with the plotting of the points. You always start at the origin. Now, you move along the x-axis first, but the point that you put always ends wherever the y ends at. So, for instance, we have A. Now, this is like a number line. We start at the origin. X is 2, so we go where X is 2. And then Y is -8. So we'll go to 2 and then we'll go down to -8 and plot our point. Now that took care of A. Now we go here to B. We have, it keeps disappearing for some reason for A, but you all see what a point is supposed to be. So we go here to B. X is -8. We go back to the origin. So we go X is -8 and Y is 2. So we plot that point here. Now we go to C. We go back to the origin. X is +9 and Y is +9. We plot that point here. Now we go to D. We have -5, -2. We still go back to the origin. We go to the left 5 and then we go down 2 and plot our point. Now we go to E. We have 0 and 7.5. So that means that X does not move. We do not move on the X-axis. We stay at the origin. But the Y is 7.5. So we will go up and plot a point right between 7 and 8. So this would be 0, 7.5. Now we go here to F. Start at the origin. Now if you notice, X is 4.3, so it's a little bit past 4, but not quite 4.5. And Y is 0. And since Y is 0, that means we stay on the X-axis. And this would be our point here. Now if you need to, you may need to rewind the video in order to get where those points were, because they keep disappearing for some reason. Okay, now we come here to the scatter diagram, also known as a scattergram or scatter plot. A graph of plotted order pairs such as the graph above. Example 4, determine the meaning of an order pair in each situation. Let X be the number of words in a document and let Y be the number of minutes it takes to type the document. What does the order pair 408 mean? Now remember, X, which is the 400, is the word in the document, is the words in the document. And 8, which is represented by the Y, is how many minutes it takes to type those 400 words. So we would say it takes 8 minutes to type 400 words. Or you could write to type 400 words, it takes 8 minutes. Either way, it's fine. Okay, B. Let X be the length of the candle and Y be the minutes since the candle was lit. What does the order pair 36 mean? Okay, so 30 represents the inches of the candle. So we could say the candle has a height of, actually it's supposed to be 30, of 30 inches after being lit for 6 minutes. So the candle has a height of 30 inches after being lit for 6 minutes. Or you could say after 6 minutes of being lit, the candle is 30 inches. Either way is fine. Okay, now it says here's a more formal and statistics-oriented definition of a scattergram we can use. A scattergram, a scatter diagram or scattergram or scatter plot is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data is represented by a point, or you could say a dot. The explanatory variable is plotted on the x-axis. The response variable is plotted on the y-axis. Points are never connected on a scatter diagram. Example 5. The scattergram below shows the relationship between the number of children per woman in a country and the country's average life expectancy in 1962. Now we know that is the year that we're dealing with here. So now it says, what is the explanatory independent variable in this case? It's the fertility rate.